Hey guys, welcome to the first video in this new series, Simply AI. The goal of this series is to first introduce a wide range of AI fields and then provide a deeper understanding on some of the more prominent topics in an easy to understand manner. Most of the subject matter can be understood without programming knowledge, but programming experience will help you gain a deeper understanding into the pragmatic use of AI in real-world applications. With that said, let's get started with today's video, Introduction to AI. Today, we will look at what is AI, what are the ethical issues and how to be responsible with AI, what are the prominent fields of AI today, and list different applications of AI that we may explore this year to understand how AI can be applied to solve real-world problems. Let us examine what is artificial intelligence, or AI for short. It has meant different things to different people at different times in history. One of the more popular perceptions is that AI is the ability of machines to mimic humans. However, that perception is not entirely accurate. It is more accurate to say that AI solves the problem through a best possible algorithm. With artificial intelligence, machines simulate human intelligent processes, but they are not limited to these human thoughts and processes. In short, with AI, machines seek the best way to solve a problem by making its own decisions and with minimal or no human intervention. So ideally, AI is not limited to human intelligence, as machines are capable of performing many operations that surpass human capabilities, and therefore they can, in theory, use means to best solve problems that could be sometimes beyond even human reach. Now with that perspective, are you beginning to feel a bit uncertain about AI? Because if machines can find optimal solutions without human interventions, can we humans really rely on these machines to always make the right decisions? Now when we say right decisions, right for whom? What about motive and morality? Well, if you're uncertain about these issues, you're not alone. These issues have long plagued the AI community, and frankly, I believe that there are no easy answers. There has been an active debate on numerous ethical issues surrounding AI. Let's examine some of these issues. The first one is biases. Will AI technologies always lead to unbiased outcomes? What if the speech recognition algorithms offer better results and lean towards a specific group of users? That may not be deliberate, but is an unintended consequence of using the technology. For example, if the majority of the training samples were from white males in West Coast states, the recognition would be biased towards that group. The second is dignity. Consider the use of AI for applications such as a medical nurse, customer service, soldier, judge, and police officers. Machines void of empathy would alienate users, and such use of AI could threaten human dignity. Add the notion of perceived bias in training of these machines, and it could quickly lead to distrust. Another issue is liability. When an autonomous vehicle kills someone in an accident, who is liable? The car owner? The car company? The government? Is it fair to let car companies state that the use of its technology is as is without holding them liable? The next issue is weaponization. AI weapons pose different dangers than human-controlled weapons. The loss of control to machines and a global arms race to ratchet up the machine lethality can have grave consequences. And lastly, opacity. AI is not always convincing. Technologies such as neural networks merely state an optimal result without explaining why that is the case. At times, this may not seem fair or trustworthy, and may indeed fail to detect and overcome bias or malfunction in its training. So not all technologies are suitable everywhere. AI has been and will continue to make a significant positive impact in every aspect of our lives. However, although we have not reached superintelligence, we have to be aware that an irresponsible use of such powerful technology can one day lead to our demise. So we need to be responsible in our researches and use of AI. Science fiction author Isaac Asimov started us out on such a path in the 1950s with his 3 laws of robotics. Law number 1. A robot may not injure a human being or, through inaction, allow a human being to come to harm. Law number 2. A robot must obey the orders given to it by human beings, except when such orders would conflict with the first law. Law number 3. A robot must protect its own existence as long as such protection does not conflict with the first or second law. Now, is this enough to put you at ease? And if not, what else do we need? What are your thoughts? Many initiatives exist today to make AI responsible. Almost all big tech companies have a responsible AI initiative. Responsible.ai provides certification for responsible AI, and numerous organizations recognize this need. Let's examine some pragmatic steps towards this responsibility. To be responsible, an AI-based solution must be explainable, justifiable, monitorable, reproducible, unbiased, secure, and human-centered. This will ensure that the use of the solution remains grounded in sound and responsible principles that lead to a fair, safe, and sustainable use of AI for the foreseeable future. Now, how many of you worked on a deep learning or neural network-based solution? Do you think your solution meets these criteria? If not, what do you think was missing, and can you think of a way to rectify it? Not easy, is it? And can you think of a way to rectify it? Not easy, is it? Deep learning solutions are not easily explainable, and if not explainable, how can you make them justifiable and monitorable? For the past few years, we have been subjected to a barrage of buzzwords and hype around AI. And let me first say this, it is not easy to make something intelligent. Each problem often requires its own unique approach. So let us try to go beyond all this hype and explore what real AI entails by examining the large expanse of fields that constitutes AI. Let me begin by dispelling the notion that AI is machine learning or deep learning. To put it very bluntly, AI is a lot more than that. To appreciate how vast this field is, let us take a look at this picture. Each box or item here represents a field full of its own techniques and algorithms, and many comprise numerous other boxes under them that I couldn't show here. Each box or item here represents a field full of its own technologies and algorithm. Each box or item here represents a field full of its own techniques and algorithms, and many comprise numerous other boxes under them that I could not show here. And deep learning is this tiny, albeit very important box right over here. Deep learning has enabled us to solve a lot of problems that could not be solved before. However, AI is much more than that. Each problem requires its own unique approach, and knowing which subfield suits the problem makes the solution much more effective. We will be visiting this picture often while we go in depth in some of these subfields. Let us quickly look at some of the important subfields. Machine learning is one of the most popular fields of AI. Here, a machine automatically discerns important patterns from large amounts of training data without the need to explicitly understand each such pattern or explicitly write a program for the tasks. For example, a machine learning system would be able to diagnose lung cancer in chest CT scans. It would do this based on patterns it learned from past CT scans that it was trained with. Computer vision interprets visual data and objects from images. For example, computer vision would be used in a robot to detect whether there's a baby in its path. Natural language processing recognizes words in human speech and text and what they mean. For example, natural language processing could be used to identify potential security threats from social media posts. Robotics is used to automate robots to perform complex tasks without human intervention. For example, it could be used to navigate unknown terrains on new planets. Reasoning is a wide collection of logic-based technologies that applies the rules of logic to solve problems. For example, it could be used to explain why a fraud is suspected in a bank loan application. Evolutionary computation features evolution guided by algorithms modeled after biological evolution processes like genetics and swarm intelligence. For example, it could be used to find an efficient plan to reduce the time and cost for a salesman traveling across multiple cities. And finally, in machine planning, there's a specific problem or a goal, and the idea is to come up with an optimal plan for that goal. For example, machine planning would feature planning by multiple combat agents to destroy a hostile enemy stronghold. Now that we saw the many fields of AI, let us explore the type of intelligence that machines offer today and in the future. The first type is reactive intelligence. This intelligence is mostly reactive as there is no memory with which it can leverage past knowledge. An example is IBM's Deep Blue playing chess against Garry Kasparov in 1997. The algorithmic approach cannot leverage past experiences. Some technologies, such as neural networks, work with past knowledge as training data, but any past experiences are baked into an algorithmic current state that cannot be dynamically adapted to new current understanding of the past events. The next type is limited memory. This intelligence is still based on limited information from the near past. There is no long-term memory that helps it analyze its experiences and react according to these past experiences. For example, a self-driving car monitors the state of other cars and objects for a limited time so that it can navigate by avoiding such objects. Most of the current AI technologies reach this level of intelligence. Next is theory of mind intelligence. This intelligence understands social aspects and human emotions so as to infer human intentions and behaviors. This understanding helps cut down required training in the same way a new employee does not need training on how to share office space with a colleague. Few technologies, such as cognitive computing, are beginning to address rudimentary aspects of this level of intelligence, but it is mostly not present today. Finally comes self-aware intelligence. This intelligence understands the self and its current state of being. It meets or exceeds human intelligence. This does not exist today and is unlikely for the foreseeable future. Once you reach this stage, hopefully with responsible AI, you're likely to encounter amicable superintelligence. That was a technology perspective of AI. Now, let us explore how we can use this technology to good use for different aspects of our lives. By exploring some of these applications, we expect to understand how AI can be applied to solve real-world problems. Based on the level of interest among members, we can add or remove more fields and projects, but today I will introduce some of the big and interesting AI applications that I have identified to make a big impact on our lives. AI has interesting applications across these four aspects: robotics, business, economics, and finance, aka the corporate world, environment and earth sciences, and medical and life sciences. Here, we explore the application of AI for robotics and intelligent machines. Autonomous learning. New trends in AI now allow machines to learn automatically without explicit training. We will explore an AI technology with numerous real-world applications to demonstrate autonomous learning. Self-driving cars and autonomous vehicles. Today, AI powers the self-driving car revolution. We will explore various AI approaches for different aspects of autonomous vehicles. Multi-agent learning. AI allows multiple agents or robots to coordinate and negotiate to perform a big task. We explore different multi-agent approaches for hard-to-solve problems. And finally, AI-based drones. AI-based drones are the future for commerce, smart cities, and urban management. We explore how drones use vision and learn to detect objects. Here, we explore the applications of AI technologies in the corporate world for business, economics, and finance. Insurance. AI can predict potential future fraud claims and offer discounts to customers. We explore how to predict and prevent frauds. Algorithmic stock market trading. AI helps to perform algorithmic trading that can learn from data without relying on the rule-based systems. we explore machine learning approaches for effective algorithmic trading. Smart supply chains. AI helps to minimize overstocking and mitigate risk of running short on in-demand products. We explore ways that AI can optimize supply chains. And finally, automated chatbots and customer service. AI enables natural language understanding and optimizing customer service by automatic chatbots. We explore how AI performs natural language processing and chatbots. Here, we explore the application of AI technology to environment and earth sciences. Energy conservation. AI can enable tremendous savings in energy using smart systems. An in-depth state-of-the-art AI system that conserves energy will provide a good insight into the real-world use of AI technology. Landslide warning. AI helps to provide rapid, early warning locations and future forecasts for landslides. We explore AI approaches for this warning system. Ocean and marine ecosystems. AI powers numerous initiatives in marine and coastal ecosystems. We explore many initiatives and impacts of AI in these ecosystems. And finally, mineral prediction and exploration. AI helps predicting mineral deposit discoveries and mineral ore quality. We explore how to discover mineral deposits. Here, we explore applications of AI technology into medical and life science. Medical imaging. AI helps doctors analyze patient scans and reports to detect and present diseases and manage treatments. We explore how to know if a patient has cancer or is at high risk of diseases such as diabetes. Drug discovery. AI helps find new uses of drugs, predict drug-protein interactions, discover drug efficacy, ensure safety biomarkers, and optimize bioactivity of molecules. We explore finding new uses of drugs and discover drug efficacy. Genomics. AI helps predicting the structure and function of genomic elements such as promoters, enhancers, or gene expression levels. AI helps predicting the structure and function of genomic elements such as promoters, enhancers, or gene expression levels. Here, we explore gene expression levels. Early disease detection. AI helps detecting many diseases such as Alzheimer's and macular degeneration type diseases in the early stages. We explore how early disease detection can be performed with AI. So in summary, today we looked at what is AI, what are the ethical issues and how to be responsible with AI, prominent fields of AI, which we'll cover some of them throughout the year, and different aspects of AI that we may explore to understand how AI can be applied to solve real-world problems. Thank you very much for listening to this introduction to AI, and I hope you join us for the next video where we will explore how to get started with AI. See you then!